Hello, it's Carly McAvoy. I'm going to work these 7 problems where we are rationalizing the denominator. They all look slightly different. And then in the next video, I will work out some problems where we have 2 terms in the denominator. And so catch that for the next one. So when I look at number 1, I have a couple of ways I could solve this, but the whole idea when we say rationalize the denominator is that we don't want a denominator we don't want a radical, in the denominator. So I'm going to start off by simplifying this, because I can say the square root of 2 is the same as the square root of 2 times the square root of 3, because 6 is 2 times 3. So I could do that, and that would leave me 1 over the square root of 3. And then the idea is that if you take a square root times itself, it cancels each other out. The radicals do, and I'll show you why that is on just this once, and then we'll just accept it for the rest of the time. But really what the square root of 3 is 3 to the 1/2 power. So if you take 3 to the 1/2 times 3 to the 1/2, you add your powers together and you get 3 to the first power. So when we take a radical times itself, a square root times itself, those two things actually make that become just 3. And then we do have on the top 1 times the square root of 3, and on the bottom just 3. And that would be rationalized because we got rid of the square root that was in the denominator. So for this second one, we don't have anything to cancel. I can just go ahead and multiply by the square root of 3x. I want to multiply by exactly what my square root expression is. And so then the square root of this to the 1/2 and this to the 1/2 adds up again to the 1, and I have the square root of 3x over 3x. Notice that I can't cancel those. 1 is in the radical, 1's not. They're not the same. I can't cancel. Sometimes you do have a square root on the top left over, sometimes you don't. You can have variables involved. In this one, I'm going to do pretty much the same thing. I have the square root of 7a, and I'm going to multiply by the square root of 7a. And again, the reason these are slightly different is just so you can see a under the radical is not the same. So what I have on top is a square root of 7a, and the denominator is just 7a. And again, square root of 7a is not the same as 7a, right? So I can't cancel those out from under like that. Here I have a square root on top to start off with that doesn't match the square root on the bottom, and I have a number out front. But I don't care if I have a whole number in the denominator. What I want to get rid of is the radical. So I'm going to multiply by the square root of 5. And on top, the square root of 3 times the square root of 5, well, those both are under a radical. So I can say that that's going to be the square root of 15. And the square root of 5 times the square root of 5 is 5, but I already had a 2 down there. So that's going to give me the square root of 15 over 10. So I need to make sure that I simplify and I use all my tools that I had before I ever encountered radicals. Before I do anything here, I'm going to simplify under the radical. I can see that 75 divided by 3 is going to be, I'm going to separate these because I think it'll be nice if I do that. So I'm going to have 75 divided by 3, which is 25, and x to the third over x to the fourth. Well, all these 3 x's will cancel, leaving 1 below here. So I don't have any more x's. And then underneath, I have the square root of 3, and then I have 1x left. Again, 3 x's over 4 x's, I have 1x left. So I simplified and I split that up into 2 before I ever did anything else. Now what I can see is I can rationalize this by multiplying just like we did up here by the square root of 3x. But I also want to recognize that the square root of 25 is 5. So I get on the top 5 square root 3x. And on the bottom, I just have 3x. Again, 5 and 3, I can't cancel anything here. I just can stop right there. Okay, when I have this one, I can multiply the denominator by the square root of 7, and I can multiply the top by the square root of 7 as well. This kind of looks like a distribution problem, like that, right? On the bottom, I'm just going to have 7. But then when I distribute that, I'm going to get 5 square root of 7 plus 7, because the square root of 7 times the square root of 7 is going to be 7 over 7. Can I just cancel those 7s? It looks like very tempting, but I can't do it because that 7 goes to the first term as well as the second term. So I can't go any further than that. I could separate those out, but it's not that useful. So I would just leave it that way. Here I can see that I have some the square root of 81, which I could make that 9. And then I can always think of this as rewriting it back under with one like this. I can separate them, or I can put them back together. As long as they're both square roots, I can do that. And so I'm going to just say, put this in here like that, so that you can see that these x's will just cancel. I don't even have to worry about that. And I know that on the top I have the square root of 81 now, and on the bottom I have the square root of 7y. Well, the top is just 9. So you always want to simplify anything that you can. And then I can multiply both the top and the bottom by the square root of 7y. And that gives me 9 square root 7y over 7y. And again, don't be tempted to cancel things that are under a radical and not under a radical. All right, that's it for this lesson. I'll see you next time.